Hello students, I hope all are you doing good. Today we will gonna solve the FLT test 10. First we will see the question and thereafter we will see the explanation. My name is Abhiraj. Let's start the solution. Now, moving to your question, the physics section I am talking about. Okay, your first question. A physical quantity, let me change the color. A physical quantity X depends on the quantity Y and Z in this way. Okay, this is the expression. A, B, C are constant. Okay, which of the following has same dimension? It is asking about which of the following have the same dimension. Okay, now as you can see in the solution, let me take it as a draw and then use the different color. Yeah, okay. As you can see, your first, you have an X is equals to AY plus B sine CZ. You know that X, the dimension of X should be equal to the dimension of AY and should be equal to the dimension of B. Yeah, as the dimension inside the means like theta is dimensionless quantity. So C and Z dash, you know C and Z dash both have same dimension. Z inverse you can say, because both belongs to theta and theta should be dimensionless. So this must have the same dimension to get cut out and get the dimensionless quantity. Again, you know the dimension of X and AY should be same and the dimension of B should be same. As you can see here, CZ equals to this. So which of them have same dimension? X and AY same, X and B has also the same dimension, CZ in the all of the above. The answer, correct answer will be all of the above. If it is asking about which has not, if it is asking about which has not, then X and A doesn't have the same dimension, but X and AY have the same dimension. You need to take care of it. So the answer will be 4. It is written 3, it is quite wrong written. You need to understand that all are correct options according to this particular question. Because X has a dimension, you know, you can only add or subtract the two quantities which have the same dimension. Okay. Now moving to your next question. If the dimension of a physical quantity represented by m to the power x, l to the power y, t to the power z, then physical quantity will be. Okay, it is asking about which is the correct option. For the velocity, you know lt minus 1 means like lt minus 1. No, it will be not correct. For force, you know mlt minus 2. It will be also not correct. For energy, you know some the dimension of the energy, that is work, is force into displacement like ml square. It is also not correct. For surface tension, okay, you know the formula of surface tension. Yeah, for the surface tension it is correct, because surface tension is simply your force per area. It's simply m to the power 1. It's independent of the L, and t to the power, sorry, t to the power minus 2. It's like m by t square. This is your basically representing the surface tension, that m1 L0 t minus 2. This is the dimension of surface tension. So the correct option will be option number 4. Now moving ahead, two projectiles A and B are projected with the same speed. Speed is same, angle are this and this, respectively horizontal. Which of the following is the correct? Now moving to the solution, you know the maximum height, you can say about it. It is asking about the maximum height and a time period. Maximum height is given by this. So as the angle is more, the h will be more. So hb is greater than ha, and the time of flight is also this. It is also depending on the angle. So more the angle, more the time of flight. So hb greater than ha, tb greater than ta. So hb greater than ha means like second, or this is wrong, because here it should be tb greater than ta. Here it is correct, because for the B the angle is more the angle will be, and more the time period will be. So option second will be the correct answer. It is wrongly written here. You need to understand it out. Okay. Now moving ahead, a particle is moved from position A to position B under the force of this. You need to calculate the work done. You know work done is equals to F vector dot dr vector. Now looking at the solution, your work is F dot dr you can say, or the delta R you can also say. Calculating it out, your work done will comes out to be this value. Just need to calculate delta R means r2 vector minus r1 vector. Put those vector and do the subtraction and you get delta r vector. Putting delta r vector dot with the fourth vector, you get the value of work done, which will be your 46 joule. Means option 4 will be your correct answer. Okay, now moving to the next question. Block of mass m placed on a rough incline with tan theta greater than mu. It's a condition of like sliding. The minimum force required to keep the block at rest. Okay, you know the block is in this way. Okay, here is the angle theta and here is a small, like this is the wedge, this is the block, and the force is acting in this way, means perpendicular to the surface. So you need to understand, you need to like do one thing. Uh, resolving this component along, or you can say perpendicular to it. Okay, or you can also resolve it in x or y direction, but it is better to resolve the component along the incline or perpendicular to the incline. As you can see here, like the force that we are getting here is totally perpendicular to it, so it doesn't have any component along the inclined plane. Okay, you need to understand it out. Now, looking at the solution, at the equilibrium, in the perpendicular direction there is the equilibrium, or in the horizontal direction there will be equilibrium. In both the directions there will be equilibrium. If in the both the direction there will be equilibrium, so you can write the equilibrium equation. In the normal direction, you have normal is equals to mg cos theta plus f, and in the like horizontal direction, your friction is only acting, and then mg sin theta is acting. Okay, the mg sin theta is equals to this. Equating these two and solving for the f, it comes out to be mg sin theta by mu minus cos theta. So your correct option will be option number 1. It's a conceptual question. A little bit you need to use the like numerical value also here. Numerical computation you can say. Now moving to the next question. A bullet of mass 10 gram moving with velocity this passes through a bag of sand. Sand offers the average friction this Newton and bullet travels 2 meters in the sand. The kinetic energy of the bullet after passing. You just need to use the like first you need to understand the kinetic energy of the final work energy theorem. You can use work energy theorem, is equals to change in the kinetic energy. So you need to calculate the work, then you know the K final and K initial, and from there you can calculate the final is zero, like initial you can understand by easily using the work energy theorem. Now moving to the solution. Kinetic energy of bullet, you can say half mv square. You can use the formula. Velocity is given. Okay, work done on the sand. Work done is equals to force into displacement. Your force is given, your displacement is given. You can calculate the work done. Now you can calculate the final kinetic energy from you by using this. And your final kinetic energy, you can say here it is asking about the energy. Okay, the energy, kinetic energy, asking about it. After calculation, it will come out to be 272.52. Your second option will be a correct answer. It's simply your work energy theorem question. No need to like worry about. You just need to use the work energy theorem, because you know the force, you know the displacement, you can calculate the work, you know the initial velocity, you can find there the final velocity. Here the like it has done mistake. You just need to use like work done is equals to k final minus k initial. Like moving with velocity, you know k initial, you know work done, you just need to calculate the k final. That will be your answer, your energy. Now moving ahead, a particle is released from s height, okay, from the surface of earth, okay, at a certain height its kinetic energy is 3 times of the potential energy. Okay, a particle reached at a particular height, when it goes down at a certain height, it is saying that its kinetic energy is 3 times its potential energy. The height from the surface of earth and the speed of the particle at this instant. But at that instant it is asking you the height from the surface of earth and the like you can say speed. Okay, you just need to understand and use the conservation of energy in that case simply. Now moving to the solution, potential energy plus kinetic energy is total energy, that is equals to like here mgh at a given point where kinetic energy plus potential energy, kinetic energy is 3 times of potential energy. Putting the value, you get the value of height, which comes out to be s by 4. So your height is s by 4. And for the kinetic energy, you just need to use this. You know height, you can calculate the potential energy, and putting the value of potential energy, you can get the kinetic energy. And that will come, from that kinetic energy, you get the value of velocity. And the velocity comes out to be root under 3 gs by 2. So the correct answer will be root under 3 gs by 2. So the correct answer will be option number 3 will be your correct answer, because here it will be like, wait for 1 second, it's 4 and getting out it's 2. Okay, sorry, it will be root 2. Then the option first will be correct answer, because you know that here it is 3 mgs by 4 and equal to half mv square. So half will correct 2 and the whole will come into under root. So option first will be your correct answer. Moving ahead, a solid of mass 2 kg is heated with delta H heat versus temperature is, change in temperature is given. Okay. What it is asking about the specific heat. Okay, it's a simple formula based question. You must know that delta heat H is equals to m times delta theta. Just you need to calculate the like m, you know m, and you know delta q or delta H from here, and sorry, ms delta theta. Like this is, you know, na, delta Q equal to ms delta T. The same formula is written here in different symbols. It doesn't matter. Symbol doesn't matter in physics, the concept that matters. From here, you can calculate the S. That will be your delta Q upon m delta T. So your m delta T. This is your S. From here, you can easily get the value of S. That will be your 0.5. Option second will be your correct answer. The displacement of two particles of the same mass executing SHM are represented by this. Okay. For which the total energy of both particles the same. Okay, it is asking what the total energy of both particles same. So means E1 is equals to E1, E2. Equating the energy of first and second, you get the condition over the omega. Now looking at the solution, you know the total energy is equals to half square omega m omega square a square. Equating the two values, you get omega is equals to 8. Means option third will be your correct answer. Means like for omega is equals to 8, both have the same energy. Now moving to the next question. What is the speed of the satellite going around the Earth in circular orbit height 2r from the circle? Okay, it's just an orbital velocity and conservation of energy concept. Okay, now moving to the solution. You know that gravitational force is equals to g m1 m2 by r square equals to mg, and at h height you can write it g m1 m2 by r plus h whole square equals to mg dash. From here you know that you can also remember this formula. At means like at certain height h, the value of g, that is g dash. Once you know it, you can easily apply the energy of conservation from here, and you can calculate the velocity, the general value of velocity. That will be your simply under root of g r radius of earth square upon r plus h. This is your general velocity. Now putting the value of h, h is your 2r. Putting the value of h 2r, your velocity will come out to be this. That is root under gr by 3. Root under gr by 3. Option second will be your correct answer. It's simply you just need to understand that what is the value of G effective at a h height, general at height from the center of the earth or from the surface of the earth, you can say. Put from the surface of the earth. Once you know that, you can easily calculate the speed over there by using the energy conservation. You can write the potential energy over there and then kinetic energy over there, and then you can easily understand the value of like what is speed at of the satellite at that particular point. Now moving ahead, six identical capacitors C are connected in the circuit. Okay, as shown in the figure. Okay, charge between capacitor lying between points A and B. Okay, it is asking about the charge between this. First, you need to understand that how like capacitor has been arranged. You can see in the solution. You can arrange this capacitor in this way. Here is your potential battery, and here your capacitor. And it is, once you can see like C, 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 and then C, C, and then C. Taking the point. This is A point, this is B, this is B, and this is B, this is B, and your this is B. Okay, and this is your some point X. This is point X. You can say A, B, or you can say like A, B, C, and X. All the capacitor is between this. So you can see it behaves and a wheat stone bridge, something like that. And as the potential, you know that there is no current flow between them, so the potential difference is same for both them. So delta V will be 0 and V will be your 0. It just given in a complex way. You just need to resolve it in a simple way and then look at out like how the potential is between that capacitor. Now moving ahead, again the equivalent resistor or something current like that. Total current supplied by the to the socket by a battery in the figure. Okay, total current is asking. It's an socket. You know there is a this and this and this and this is a point. Okay, you know, like it's 10 volt, 10 volt, 10 volt, 10 volt, and then 0 volt, 0 volt, 0 volt. You know, here if you take 0 volt, it's 0 volt, it's 0 volt. Here it is 10 volt, here it is 10 volt, and here it is 10 volt. Okay, you just 10, 0, and X. You can resolve in this way, and by this you can calculate the battery here, and you can solve it out. It's a simple question. Yeah, if you see the resolve form, this will be this. These two are parallel, it will be in series with this, and then they are parallel. Putting that, you can calculate the R equivalent, and then you know the potential, then you can calculate the I equivalent current. That comes out to be 55 by 12 ampere. That's option second will be your correct answer. Now moving to the next question. The time period of a satellite is related to the density of the Earth. Okay, it's you can say in the form of yeah, exactly. You can write in the time period in the form of density. You know the value of time period in form of mass and all. You can write it in terms of density. Now looking at the solution, you know the orbital velocity will be this. Orbital velocity will be simply 2 pi r by t. From here you get the time period. And time period in terms of density, it will come out to be time period is proportional to 1 by root under density. That will be density to the power minus 1 by 2 is directly proportional to the density to the power minus 1 by 2. Now moving ahead, a charge Q is placed at the center of a cubical vessel which has the electric flux through the complete vessel is Q by complete vessel. Okay, charge is placed at the center of a cubical vessel with okay one phase open. One phase open. You know the flux total will be simply your Q by epsilon naught, and flux total will be this, and from one surface you know Q by 6 epsilon naught. So you can minus Q by epsilon naught minus 6 you get from the like from the one you know this. If you remove the one space after solving it out, it gets 5 Q by 6 epsilon naught after subtracting because there is no one phase. So you must need to subtract the one phase from the total flux getting out of the cubical vessel. So it will come out to be 5 like 5 2 by 6 epsilon naught. Okay. Now moving ahead, two bulbs A and B of 25 watt and 100 watt rated the voltages. You know the power, you know the voltage. You know power equals to V upon R. You get the resistance of this, and the resistance will be fixed for bulb A and bulb B. Connected in series. Okay, ठीक है. Across the 440. Okay, 440 volt. It's connected in series. Which bulb will fuse? It's asking what which bulb will fuse. You just need to understand the like current and the supply through the current. You know the resistance from the information, and then you need to calculate the current through it. Then you can really understand which bulb will fuse. Now looking at the solution, RA you know easily, RB you know easily, current through you know one easily, current through you know one two easily. Total current will be this, and current through one you can say. As you know, like I is greater than IA, मतलब means like the total current supply, like you know RA, you know V, you suppose you have a bulb that's power that has a potential. You know the what is the value of current passing through. What is the maximum value of current that it can go through that bulb? If that maximum current is is equal or greater than the total current supply on the circuit, then it will be not fused. If the total supply is like the total current will be greater than the individual maximum current, then both the bulb will fuse. As you can see here, the total current is greater than the current through the first A bulb. So it will be fused, but not bulb B. So A will be fused. Like option A will be one will be a correct answer. Now moving ahead. A long wire bends into a figure carries the current if the semicircular portion, the magnetic field at the center. Okay, it is in this way. You know, this is infinite wire. At one end, you know the magnetic field. This is also infinite wire. One end, you know, and in the semicircular circle, like circle, you know the center. You just need to add all the three magnetic fields and nothing else. Looking at the solution, you know due to semicircular mu naught. This is the formula mu naught by 4, mu naught I by 4a. This is your formula. You can say here like this is a semicircular path, and the factor resultant field you need to understand, and the due to the like a straight wire at the one end, your magnetic field will be this. So there is a two wires, so the second magnetic field is this. You need to take care of the direction. For the first, the direction will be in this, and for the second, it will be in downward. So there is a 90-degree between them. So net electric field magnitude will be B is equals to under root of B1 square plus B2 square. After solving it out, your magnetic field comes out to be this value. That will be your option number second. So it's simply you just need to use a standard formula. You need to separate this into three elements, two straight and one semicircular, and thus you need to understand the like formula that has been used here and the direction of both. And both are at the perpendicular. So at point C, you just need to calculate the magnitude of the net electric field to all this system. Now moving ahead, like so next question. A sinusoidal voltage frequency is given, peak voltage is given, LR circuit. Okay, it's a question of LR circuit. LR circuit. What is the amplitude of the voltage? Okay, it's asking about the peak voltage. It's a simple question. You know the resistor, you know the L, you can calculate the X, XL, and you can calculate the Z. Okay, and for voltage, peak voltage, you can easily calculate. You can know peak voltage. I know I is equals to peak voltage by Z. So from here you can get the peak voltage. Now looking at the solution, you get the XL, you get R, and from here you can get Z, that under root R square plus XL square, that will be this. From here you can get the voltage, you know the current, and peak voltage is your I naught into XL, amplitude across the, okay, oh sorry, it is asking about peak voltage, so from here you get this value. What peak voltage, you know that the peak voltage is given, amplitude of the voltage is given, you know about the, okay, along the conductor. Okay, so along the inductor, you just need to understand as XL and I naught. This will be your answer. So after solving out, it gets 90 volts. Now moving ahead, charge particle of 2 kg and 2 coulomb charge moves with a velocity this in a magnetic field range. The path of the maybe this. Okay, it is asking about the trajectory. Okay, you need to understand the trajectory. So first you need to understand, you know the velocity, which is and you know the like magnetic field, that is constant k Tesla, and you know the mass and charge, everything you know. You just need to understand the like radius of it. Now moving to the solution, since the magnetic field in the k direction, z direction, particle will execute circular motion in xy plane. Okay, and you know the radius of the circle. By using the formula, you can the radius, and time period will be this. So simply your time period will be this, and radius will be this. So option like A and C will be your correct answer. Like option A and C, because it will move in the circular orbit with a time period this and radius this. Okay, that is a 5 square in the xy plane. So option like option A will be also correct, and option C. So one or three both will be correct. If there is like by this equation we know that the center of the circle is 0 0. If it is not possible, then option A will be wrong and option C will be correct. So if you ask me that maybe it is asking now, maybe this. So it can be also the possible answer, but most appropriate will be your this option number third. But I will go for one or three also. You know the reason about it. Moving ahead, plane electromagnetic wave frequency is given, positive x direction. At a particular point in space, electric field is this, magnetic field. You know, electric field, the relation between the magnitude of electric field and the magnetic field, that E is equals to BC. From here you get B. The magnitude of B, you know, will come out to be this, and from here you can understand the direction. As you know, electric field, sorry, wave in the x direction. This is in the J direction, so magnetic field will be in the K direction. So you know the magnitude and you know the direction. By magnitude and direction, you can say that option C will be, means third will be correct answer. Now moving ahead, A separation between a point source of light and a screen having increased the intensity on the screen will be. Okay, it is asking for the screen. You know that the intensity is proportional, inversely proportional to d square. If it is 0.5, it will be a square of it, and your simple change will be like what is the decrease, like change, it is asking for the change. Now moving to the solution, you know that the intensity is proportional to this way, and if you know, if you want to calculate delta I upon I, that will be your minus 2 delta d upon d, that will be your minus 2 in this way. And if the delta d by d is equals to 0.5, then it will come out to be minus 1%. So decrease by 1%. This will be your answer. Now moving ahead, it is asking digital circuit that can be used repetitively. Okay, that can be used in many. It is only the NAND gate that can be used to form other gates also. It's a complete theoretical question. You need to understand it about. Now moving ahead. In an experiment, Young's experiment, interference is observed using the wave associated electron. The electrons are being produced by electron gun in order to increase the fringe width. You know beta. You know the formula of beta, that's lambda d by d. So to increase the fringe width, you just need to understand that you need to increase what you can say. Okay, it is asking about the oscillating voltage. So you need to understand, put the lambda in this form, and you can easily understand that if V is decreased, V is decreased, or you can say that V is decreased, lambda will increase, and hence lambda will increase, the beta will increase. So the correct answer will be like voltage should be decreased. If oscillating voltage will decrease, your lambda will increase, and once your lambda will increase, your fringe width will increase. Moving ahead, lights of two different frequencies of photon have energy this and this respectively illuminated on the surface. The work function is this. Okay, you know both will allow the electron to come out as the like the energy that is falling is greater than the work function. Ratio of the maximum speed. Okay, you first need to calculate the kinetic energy first, kinetic energy second, then take the ratio. That will be equal to the ratio of the, no, it will be v1 square by v2 square. From here, taking the root, you get the v1 by v2. After solving, you can see in the solution, taking the ratio of it, you get v1 by v2 is equals to 1 upon 2. So your 1 ratio 2 will be your correct answer. Now moving ahead, de Broglie wavelength of electron on a ground state of hydrogen where radius of the first. Okay, it is also de Broglie wavelength. It's simple question. Now moving to the solution, you know de Broglie with h upon mv, and from here, more posture, you know angular momentum is nh upon 2 pi. Therefore, combining these equations, you get lambda is equals to 2 pi r by n. Or you also remember in the theory, lambda is proportional to r by n. Putting all the values, you get lambda is equals to 3.33 angstrom. Now moving ahead, it's a question of Wheatstone bridge. Okay, a Wheatstone bridge has resistance 10 ohm, this ohm, and this ohm in 4 arms. Okay, what is the resistance joined to 30 ohm that will bring in a balanced condition? Okay, you just need to remember the balance condition and put that resistance will be x and apply the balance condition and get the value of x. As you can see here, just suppose x will be added and solving it out, you get r is equals to simply 15 ohm. 15 ohm will be in parallel. So you just need to understand or apply the balance condition. You know the balance condition, like if this is a resistor, this is a resistor, this is a resistor, this is a resistor. Here let's suppose you apply a resistor, so you know this by this equal to this by this. Taking all the ratios equal, you get from here the value of x. That will be your 50 ohm resistance joined in the parallel. Now moving ahead, the magnitude and the direction of current in the following circuit. Okay, magnitude and direction of current is okay. Okay, it's two circuits, both are in opposite, so net will be your 5 volts, that will be in this direction. So you can calculate the current easily. Current will be this, and it will be in the direction from A to B. You can see here. So correct option will be 0.5 from A to B. Yeah. Second option is the correct answer. Now moving ahead, an electromagnetic wave travels along Z. Okay, k cap is the direction of wave vector here. Which other for space time varying will generate this wave? You know x or y. Okay, y or x. Okay, so these two will be like that. Okay, it is positive z direction. So x cross y can only give the positive z, not because you know that the k vector propagation vector is given by e vector cross b vector. So e will be in, if e will be in y and x, so y cross x will give minus z. So only first option will be the correct answer, and it is in the plus z axis. If it is like in both, so first and second will be correct. But if it is plus z, first will be correct. If it is minus z, second will be correct. Understand? Now moving ahead. A prism angle A is given, refractive index is given. Okay, you know the formula like mu is equals to simply your sine A plus delta by 2 by sine A by 2. From here you know A, you know delta, you know A by 2. You just need to, you know, sorry, you know you calculate the delta. By solving it out, your delta will come out to be 30 degrees. Because you know the refractive index, you know the prism angle, you just need to calculate the delta. You can see the solution. From here you get the delta is equals to 30 degrees. His option first is correct. As you can see that the most of the questions are formula based and you just need to use how to apply, understand how to apply the formula to the particular situation. Okay. Now moving to the ahead. It is telling erect means positive. HI will be in the same direction as HO. Three times magnification is given. Concave mirror, focal length is negative. Radius of curvature is given. It's a simple formula based question. You just need to understand, like, take the relation, use the magnification. Magnification is equals to hi by ho is equals to minus v by u. From here you get the relation between v and u and use the mirror formula 1 by f equals to 1 by v plus 1 by u and solve for u. That will be your minus 12 centimeters. So option first will be the correct answer. Now moving ahead, the refractive index of a glass for a light wavelength is this. If the its wavelength in its wavelength in glass is okay. It's asking about the wavelength. You know the wavelength in medium is equals to like L naught by mu. So from here you know this and you know the refractive index. You can calculate the delta and that will come out to be your 4000 angstrom. It's again a formula based question. Moving ahead. When a light propagates through a material medium of refractive relative permittivity this and relative permeability this. Velocity, you know velocity is equal to c by mu. That will be c by under root of mu r epsilon r. So this option 4 will be your correct answer. Now moving ahead, three electric bulbs 200 watt resistors are connected in this way. The resultant power of the combination when operated is now. Okay, it's asking about the resultant power. You know power is a scalar quantity. So resultant power will be P1 plus P2 plus P3. Okay, 200 watt and like this. Okay, okay. You know the power and you know the like okay, all are 100 watt. Okay, okay. So, I'm just looking like if voltage is not given for each one or not. So you know the power, you know the voltage, you know the power, you know the voltage, you know the power, you know the voltage. You can calculate the R. Now moving to the solution, you can calculate all the R. And from R you can easily calculate the current. And once you calculate the current, you can calculate the power. Power through the current that will be I square R. So I square I1 R1 plus I2 R2 plus I3 R3. You just need to use this formula and get the total net power. Because it is asking about the total combination power. So combination will always act in such a way to respect all the like bulbs, not just in some way. If some bulb will fuse here, if the current through that bulb will be greater than the maximum current through that bulb, but it has been adjusted here so that no bulb will be fused and hence you need to calculate the net power, that will be your 200 volt. Now moving ahead, okay, concept of transformer, sorry. Connected in a AC supply, 220 volt is made to operate 11 volt, 1200 volt. Ignoring the power law, what is the current through the primary coil? Okay, you just need to use the condition of balance or like transformer. Moving to the solution, the power loss is zero, efficiency is 100%. So power means like secondary or primary, like primary power is equals to secondary power. So V primary I primary equals to V secondary I secondary. By using this, you can calculate the primary current, that will be 0.2 ampere. The second option will be the correct answer. You just need to understand or use the concept or the like condition of the transformer. 34 question. At frequency omega naught, the reactance, okay, it is also reactant of a certain capacitor will be equal to, okay, that's a certain, okay. It's like XL equals to XC, means resonance condition it is telling. If the frequency changes to omega naught, it is a resonance condition. And if it changes to 2 omega naught, then it is asking about the, it's a simple question. You need to understand that first, for the first case, XL equal to XC. From here, you know the condition of like like from there you understand what will be your like reason, and xl equals to omega l and equals to 1 by omega c. From here you know the L1 by C1 for omega given. If it is 2 omega, you again know this, and just you need to put the ratio and find the value. Putting the value, you know XL2 by XC2 will be your 4 is to 1. You just need to use those conditions like XL equal to XC in the two times. First for the omega naught and second for the 2 omega naught. And once you put in the 2 omega naught, you get 2 outside, and thereafter you can put the value from the first equation and get the relation. You know it has been used for the first time and then again for the second time. And during use of the second time, you use the first equation and put the value, and you get x like xn2 by xc2, that is the 4 is to 1. Now moving ahead, LCR circuit is asking the potential difference across each element. Okay, delta V across each, it is 6 volt. Now the value of resistance is double the potential across. Okay, now if the value is double, you know, moving to the solution, circuit is in resonance. The circuit will be only in resonance if all the potentials are equal. 60 as 60 volt along each, so it will be in resonance. Okay. Now, if R is double, the current through the circle will decrease. Obviously, it is a condition. So you know that the current will decrease. So from here, you can understand that what it is asking. It is asking about the VR, okay, and then VL, then VC. You know, VC is equals to XC, IC, VL, XL, IL, VR, IR. You know, VL, IXL, IXC. It will be 30 volt. And VR, you know, if the resistance is decreased, your VR will decrease. So simply it's become the 60 volt. So VR will be this, and VL and VC will be half. So 30 volt. So 60, 30, 30. Or you can say 60, 30, 30. So the option first will be your correct answer. Means like you know, in the resonance condition, the potential drop across all the elements will be same. If the resistor will be half, then the potential means the current through all sockets in a series will be half. For the currents will be half, you can easily find out the value of potential for each will be like 60 by 2, 60 by 2 for the next second, and your like 60 for the resistor value. Now moving to the next section, an electric device draw enough power from AC voltage is the current lags. Okay, current lags here. Okay, current lags here. Now it is asking about the resistance of the circuit. Now moving to the solution, you know power. Power is equals to P cos, or you can say like power is equals to what? P cos phi, and P is equals to V square by R Z. So this is P and this is cos phi power factor. From here you can easily get the value of Z. And once you get the value of Z, you can calculate cos phi, that is power factor, that is R by Z. And you know R by Z, that is 4 by 5. And you know the Z, you can calculate the R, and R will come out to be 12.8 ohm. Option 4 will be your correct answer. Now moving ahead, the frequency of first overtone of a closed pipe is 60 ohm. Okay. The frequency of third overtone. You just need to the fundamental frequency, that is 3V by 4F. So you just need to understand the frequency. So from here you get V by L for the 60 ohm. Once you know the V value which is constant for this, so you can calculate the third frequency, that will be your 7V by 4L. You know V by L from the first expression. Put the value of V by L and get the value of F3. You can see here the same has been done here. You get once you get the V by L, which will be the same for that pipe, and use that expression in your second required expression what you want as a result. Putting that value, you get F3 will be 140 Hertz. That will be your frequency. That option like 1 will be the correct answer. Now moving ahead, a particle of mass 1 kg perform SHM given in this way. What will the kinetic energy? You know the kinetic energy or potential energy and the total energy. You just need to understand half mv square. You know why v you can calculate by y dot, that is dy by dt. Okay, at t equal to 2 seconds. You know the velocity from here. Once you know the velocity, you just put the value half mv square. And once you put the value, it will come out to be pi square by 288 joule. Option first will be your correct answer. It's again a formula based question. Now moving ahead, the motion of a particle is expressed by this. Okay, acceleration and displacement. The time period will be what? You know acceleration is proportional to minus x, so it is SSM. So here minus omega square x. It will be omega. Omega is equals to root under b. So you know omega is equals to root under b. So you know time period for that SSM will be 2 pi. Time period will be what? You know 2 pi by t. So it will be simply c equals to 2 pi by root b. So option third will be your correct answer. It's again a formula based question. You need to understand. Okay, wait. Omega is equals to 2 pi by t. 2 pi by t is equals to root under b. So your time period will be 2 pi by root under b. So option third will be your correct answer. Here it is wrongly mentioned like, because you know the omega now, and omega you know 2 pi by t, because omega square is b. So omega is equals to root under b, and omega you know 2 pi f, and f is 1 by t, so 2 pi by t. From here t you know 1 by root under 2 pi by root under b. So your correct answer will be option number 3. Moving ahead, a set of n resistors each are connected in series. A battery of EMF internal R current I is observed. If n resistors are connected in parallel for the same battery, the current increase 5 times the value of n. Okay, it is asking about the value of n. First, you need to calculate for the series condition, then going to the parallel. Now, moving to the solution. For the series, you know, simply your I will be same for all, that is E by total, like total series internal resistance plus NR. From here, you know I1. Okay, sorry, I. And for the parallel condition, you know all are in parallel. For all are in the parallel, you just need to understand that the total current will be EMF by R equivalent, that will be R plus R by N. This is your full condition for the parallel, and this is for the series. And it is saying that parallel will 5 times of series. From here you get the value of n. Just solve and get the value of n. Your n will be come out to be, solving it, n will come out to be value of 5. N will be your 5. Option third will be your correct answer. Now moving ahead, when the deforming force, okay, is applied to a body parallel to its surface, its shape changes not size. The strain producing, it's asking about the strain. It's simply you know shear strain. If the, like you can see in the explanation, when a deforming force is applied to a body parallel to its surface, like you can say that the surface of this and parallel to this, its shape doesn't change. The strain is produced in this manner called shear stress or tangential stress, you can say. Shape, size doesn't change, shape changes. Like it becomes in this way, or you can say in this way it becomes. Size will remain the same, but shape changes. Now moving ahead, momentum is a circular wire of mass m, radius about its diameter. It's simply a disk that's mr square by 2. Option number first will be your correct answer. Consider the uniform square plate side A and momentum is a plate axis perpendicular plane passing through one of its corners. You know about the center, you just need to use the parallel axis theorem. You know about the center, the value, you just need to use the parallel axis theorem. From here, you can easily get that about the center, that is ma square by 6. So using parallel, ma square by 6 plus md square, where d will be a by root 2 square. From here, you get the value of about the corner, that is 2 by 3 ma square. Option 4 will be your correct answer. Now moving ahead, ionization energy of hydrogen like atom A is greater than the another hydrogen atom B if RU and E represent radius of the orbit, special energy this, or the and angular momentum of electron respectively. Then the ground state will be. In ground state, it is asking about the what will be the result in the ground state. Now moving a solution, you know if the ionization energy A is greater than that of a B, the atomic radius of A is greater than that of B. And from energy, you know minus 13 consist z square by m square where n is equals to 1. And relation of speed of electron, you know U is equals to this and R equals to this. You can understand that U is proportional to root under Z, and so UA is greater than UB. That is your simply speed of electron A is greater than in the B. So your second option will be the correct answer. Now moving ahead, which of the following is true for Lyman series of hydrogen atom? Okay, Lyman series is again a like fundamental or theoretical question. Lyman lies in UV. You know first Lyman, Balmer. Okay, yeah, it's UV. It involves jump of electron from involves jump to or from ground state. Largest wavelength will be this. Yeah, in the same, you know, involves jump from the ground because first Lyman, that will be final will be your ground and initial will be any. So jump to from ground. So second will be correct for one or second both will be your correct answer. Now moving ahead, in whole atom hydrogen, which of the following is quantized? Okay, linear momentum, angular momentum. Okay, MVR will be quantized. 46 third complete theoretical question. Now moving ahead, the potential energy of a particle in a force field is given by this. You know, like force is equals to minus du by dr. From here you can get the value of force. Where A and B are positive constant for a stable equilibrium. For a stable equilibrium, you know force is equals to 0 and d square u by dr square means potential energy should be negative. Potential energy should be negative. It's like first derivative, you know, force is 0 and it's like which part? It's your minima and minima occurs for less than 0, sorry, greater than 0. This is a stable condition. So by using the condition, you can see in the explanation, a stable condition, you get the condition on A upon B. That will be this. So for a stable condition, it will be R will be 2A by C. Option second will be your correct answer. You just need to understand, you know the E, you just need to calculate d square u by dr square and putting it greater than 0. And once you putting it greater than 0, for the stable equilibrium point, is like where force is 0. Putting that point here, if it comes out to be positive, then this point will be a stable equilibrium. If it will be negative, then this point will be an unstable equilibrium. Now moving ahead, two parallel metal plates have charges fetching in a certain distance deep into a water. The plates keep in air keeping on charge on a plate. The distance between plates shape the electric field between. You just need to understand once it will like dip into a material, the electric field decrease by epsilon r time. So it will decrease simply. Or what is asking? It is asking about the electric plates field between the plates after when. You know that in dielectric medium, electric field will be what? Sigma by epsilon naught into k or epsilon naught means like E dash will be E times k. So you know once it dips into the uh, water, electric field will decrease. So in the water it will decrease, for air it will increase. Now moving ahead, a point charge this is placed at the 10 centimeter directly above the corner of a square plate. The square side 10, magnitude of electric flux. Okay, from the you can make the cube, and from one surface it's simply q by 24 epsilon naught. You can understand it by using the concept. From one face you know this, and you can like convert it into four squares, and then you can understand it out. And once from the one face you know the flux will be simply q by 6 epsilon naught. So if this one face is divided into four corners, so your flux will be through one will be like if you complete this out, it will take around four squares. Okay, so for one face, take it in this way now. Like if there is a complete face, your flux will be q by 6 epsilon naught. But this face in four parts, it will be become the corner of one face. So it will decrease by 1 by 4 times. So your answer will be q by 24 epsilon naught. Just putting the value here and solving it out, you get the value of the total flux through the corner. That will be your option number 4. 9.4. Now moving ahead, body is sliding up on incline with a speed as shown in the figure. US and UK is the coefficient of static and kinetic friction in the friction force between the block and inclined plane. It is asking about the frictional force between them. Limiting friction will be what? Mu k or into n, and your mg cos theta. So your limiting friction simply your mu k mg cos theta. Because mu s is not correct, because for the mu s the friction force will be self-adjusting. It will be again is equals to the external applied force. So limiting friction, that will be equals to the kinetic friction, that will be the value of maximum friction that it can get, that will be simply your mu k times mg cos theta. That will be your normal, balancing the normal is equals to mg cos theta. So your third option will be your correct answer. So we have completed the solution of all 50 questions, and I hope you understand the explanation. You can see that the most important point is the formula and its application. Even if you find any doubt, you can put it in the comment box and I will try to answer those comments if possible. Thank you very much.